So, good day everyone. So, for today, i-discuss ko yung parabolic PDE at magbibigay ako ng isang example kung paano isolve yun. So, here is the example. A metal bar of length is 0.08 meter is subjected to a temperature of 95 degrees Celsius on the left end and 31 degrees Celsius in the right end. Find the temperature distribution in the metal bar when time is equals to 20 seconds from the interval of time equals 0 and time is equals to 40 seconds. So, delta x is equals to 0.02 meter and delta t is equals to 20 seconds. So, given P is equals to 7,600 kilogram per cubic meter and C is equals to 470 joule over kilogram per K, kilonewton, and K is equals to 53 W over M times K. So, 19 degrees Celsius is the initial temperature of metal bar. So, solution. Alpha is equals to 53 over 7,600 kilogram per cubic meter times 470 is equals to 1.4838 times 10 raised to negative 6 meters squared per second. Then, lambda is equals to alpha times delta time over delta x squared is equals to 1.4838 times 10 raised to 5 times meters squared per seconds times 20 seconds over 0.02 meters squared is equals to 0.7419. Number of time steps is equals to final time and initial time over delta time is equals to 40 seconds minus 0 over 20 seconds is equals to 2. So, the boundary conditions are T sub 0 to J is equals to 95 degrees Celsius, comma T 4 to 3 is equals to 31 degrees Celsius. So, for all J is equals to 0, 1, 2. All temperature of the roads are at 19 degrees Celsius when time is equals to 0 seconds except the boundary condition. So, T 0 to 0 is equals to 95 degrees Celsius. T 1 to 0 is equals to T 2 to 0. T 3 to 0 is equals to 19 degrees Celsius and T 4 to 0 is equals to 31 degrees Celsius. So, temperature of the roads when T is equals to 20 seconds. Setting J is equals to 0 and I is equals to 0, 1, 2, 3, 4. So, T1 to 0, T1 to 1 is equals to T10 plus I times T2 to 0 minus 2T1 to 0 plus T sub 0 raised to 0 is equals to 19 degrees Celsius plus 0.7419 times 19 degrees Celsius minus 2 times 19 degrees Celsius plus 95 degrees Celsius, which is T1 to 1 is equivalent of 75.4 degrees Celsius. So, next is T sub 2 raised to 1 is equals to T sub 2 raised to 0 plus na ng 2 sub 3 raised to 0 minus 2 T sub 0 raised to 0 plus T sub 1 raised to 0 times 19 degrees Celsius plus 0.7419 times 19 degrees Celsius minus 2 times 19 degrees Celsius plus 19 degrees Celsius. So, T sub 0 raised to 1 is equals to 19 degrees Celsius. So, T sub 3 raised to 1 is equals to t sub 3 raised to 0 plus na times t sub 1 raised to 0 minus 2t sub 3 raised to 0 plus 2 plus t sub 2 raised to 0 is equals to 19 degrees Celsius plus 0.7419 times 3 1 raised to degrees Celsius minus 2 times 19 degrees Celsius plus 19 degrees Celsius. So, T sub 3 raised to 1 is equals to 27.9 degrees Celsius. So, T sub 4 raised to 1 is equivalent of 31 degrees Celsius, which is a boundary condition, and T sub 0 raised to 0 is equivalent of 35 degrees Celsius, which is a boundary condition 2. Which is 0, boundary condition 2. So, the answers are T sub 1 raised to 1 is equals to 75.4 degrees Celsius, T sub 2 raised to 1 is equals to 19 degrees Celsius, T sub 3 raised to 1 is equals to 27.9 degrees Celsius, and T sub 4 is equal to 31 degrees Celsius.